Hi everyone, welcome to our Supergen Smart Charging webinar. The webinar is an activity of the Vehicle Grid Integration Group at the Alan Turing Institute. The Alan Turing Institute is the National Institute in the UK for data science and artificial intelligence. And one of the objectives of the Institute is to apply data science to real-world problems, such as what we are doing at the Vehicle Integration Group, where we are developing tools to help decarbonize transport and electricity infrastructure. We've had several episodes on the webinar already covering communication protocols for the electric vehicle ecosystem, but also plans about charging infrastructure rollout, both in certain regions, such as California, for example, but also national, such as Denmark. We also had sessions on cybersecurity. And you can find previous episodes by searching for the Smart Charging webinar, and you'll have the landing page and the playlist available to you. Next week, we are hosting a talk about local flexibility models, local flexibility markets, the developments and regulations. And our speaker is from the University of Cambridge, Karim Anaya. Next week, our talk is going to start earlier at 11 a.m. instead of the usual 4 p.m. Now, without further ado, today, I'm delighted to host Giuseppe Prettico from the Joint Research Centre of the European Commission, who's going to speak to us about DiNeMo, the Distribution Network Models platform. If you have questions, please put them in the text box and we take them towards the end. Giuseppe, over to you.
Hello, everyone. Can you hear me?
Yes, we can hear you and we can see you.
Great. I will then share my screen, my slides. I think you can also see them. So, okay, thank you very much, Myriam, for the nice introduction, and thank you for inviting me to this nice series of webinars that you're organizing at the Newcastle University and the Alan Turing Institute. So today I'd like to present you, for those of you who are not really aware about it, the DiNeMo platform. DiNeMo comes from distribution network models. And I'll provide you with a, say, overview of the project. And then in the final, say, part of this meeting, of this webinar, I will give you some more detail about the platform, how it works, etc. So we can go. This is the outline. As I was mentioning, I'll provide you an overview of DiNeMo, what is in a nutshell. Then I will move to the distribution system operator observatory, which is actually the pillar, the data set, which is at the base of the DiNeMo platform. I will provide you with the concept of representative networks or reference networks, synthetic networks, depends on, say, from which school you are. And finally, I'll provide you with an idea of the working of the DiNeMo tool, and conclude after and having done a Q&A session to try to say respond to some questions. So let's start. This is actually the new version of the DiNeMo platform. The first alpha version is already there online. But okay, we'd like to make the platform more user-friendly, but I will assume that you don't know about DiNeMo and really explain everything from the beginning. So in the new version, there will be this registration. If you're not registered, you will have to do it through an EU login. And then if you register instead, you can log in into the platform. So DiNeMo is our platform that wants to provide stakeholders in the electricity sector with a solid tool that is based on real data, which are provided from a distribution system or network operators in Europe, and which is capable of reproducing representative distribution grids of a given area of interest, which can be a neighborhood, a part of a city. We will see later through some images what we can do through it. So the platform aims to become a virtual place where diverse users, so not only scientists, researchers, electrical engineers, but we want also, and we are already see the interest from small companies or even big companies, startups, and also for interest from distribution system operators, which actually are providing the data, even though, as I will make clear later, the data are not, cannot be shared with anyone, but the platform is based on real data. And so can be of interest for all those stakeholders which work into, for example, projects of smart grid or electric vehicle integration, storage integration into, say, given areas of cities or pilot projects. So by providing these reliable, these validated network models, we would like in some way to help designing and developing the smart cities that we imagine for tomorrow. Let's make a step back, how everything started. The distribution system operator observatory started in 2015 at the beginning to deepen our understanding of the different technical features that exist between different network operators in the different European member states. With this data, we were able at the first stage to build several indicators which were used to provide first benchmark and especially a nice picture of the difference that exists at European level between different grid operators. As you see here below in the picture, while for the transmission system there is quite consolidated knowledge and smartening of the system, the same cannot be said for the distribution system, which is quite big in terms of assets, substation, cables, number of customers connected to it. So it's quite more complicated to have a thorough knowledge of it. And so we would like to help tackling this gap, this knowledge gap. So our target were not all the distribution system operators in Europe, which are more than 2,400, but only those which serve more than 100,000 customers. Let's call them the big ones, which have, moreover, to comply with the unbundling provision set in the third energy package. Until 2018, we managed to collect information from 99 out of 189 DSOs, which are the big ones. And actually, 2 weeks ago, we closed the last collection exercise of the DSO Observatory 2020, which will be actually the main data set discussed in our next report that we will be published by the end of this year. Okay. From the data set, we could say organize the data into 3 main categories: what we define as network structure, network design, and distributed generation connected to the networks. There are several indicators. I want just here to give some of them as an example, because these are those that actually will be used inside the Dynamo platform, and we'll see this later. The network structure, for example, include low voltage consumers per medium voltage to low voltage substation, low voltage and medium voltage underground and overhead ratios, transformation capacity of medium voltage to low voltage substation. For network design, we have typical transformation capacity of high voltage to medium voltage substation, average number of medium voltage to low voltage substation per feeder, voltage levels. While for distributed generation, for example, we have total installed capacity at the distribution level, percentages of their distributed energy resources connected at low voltage, medium voltage, or high voltage level. Now let's move to the concept of representative networks. What we have here are 2 of the 13 representative networks that have been built in the first phase of our DSO Observatory project. The top left, you see an urban network And let me provide some information about this picture. We have here something like 12,735 consumers, which have a peak demand of 56, almost 57 megawatt, 38 medium voltage consumers with the peak power of 5.7 megawatt. And as you can see, we have 126 medium voltage to low voltage substation and 1 high voltage to medium voltage substation. So all representative networks start from the high voltage to medium voltage substation and go down through the feeders, through the different medium voltage to low voltage substation, down to the low voltage consumers. As you can see here in the top left, we have a urban part, and say the area which is covered by the representative network, the urban one, is covering more or less 2 by 2 kilometers. While if we look below, we have here in this case a semi-urban network. In this case, we see that we're covering 5 kilometers, almost by 5 kilometers square of area, because clearly the density is lower than that of the urban area. So this is something that we need to take into account once, especially in our, say, design of the platform. Something that I want to mention about these two models, actually there is another one that is a rural, which is again a larger scale one, and there are also 10 feeder type networks, which mainly comprehend those topologies which are more commonly used by distribution system operators in Europe. All these models are available at this URL that is CircABC. And in this CircABC platform, there are, say, in groups, and the one to ask for access is the JRC distribution reference network models. Once you get access to the group, you can get the 13 models in a zip folder, and you can use for your analysis. Actually, as soon we share this, say, with everyone on our website or in our papers, in our reports, we got a lot of interest, really, and we were really keen on this. Actually, it was quite rewarding that after a lot of work done, this was of really interest of so many research institutes, but also companies which wanted to try to understand what are these representative networks and how useful they can be for their daily work. So since there was this much interest in our representative networks, I pushed to do something actually even better. Because one limitation of these models is that they have been built on the average values. These actually are the median of the European indicators, those indicators that I was mentioning before in this part on network structure, design, and distributed generation. So to overcome this issue, what actually I thought what could be really of, say, interest for people was to have, say, a platform where a user which has a given knowledge about the area of interest, imagine that they are working on a pilot or something like this, can really share this information with the platform and use the real data that, for example, we have inside the platform that is actually shared with us by distribution system operator of areas, not perhaps only this small area, but perhaps big part like the country or perhaps the province or the city, and having a network which is quite realistic. For this reason, we call them not synthetic, but representative, because they are not just, say, toy models, toy networks. No, these are built on parameters which are really close to reality. And so actually this, this motivation brought us to build and to work for some years now, 3 years perhaps, on the development and the design before on DiNeMo. So in more detail, once you are logged in into the platform, you enter in this that we call the dashboard. And on the left side, you see the network computations that you have done. For example, as you can see, the computation can be in draft. This means that I've provided data, but not all of them are there. So I just save as draft. And for example, as you can see there, the white line, first test after COVID-19, which was the first test that I was trying to do once I came back to the office. In this case, the request has been submitted and is queued, so it has been sent to the server, which will make the computation. But to make a new one, I have to click on this, add new network computation request, and start, say, to provide the information and to do what I need. For example, first of all, I need to provide a title, and instead of using sometimes very fancy titles, it's better to give some structure to the title. For example, I use this. I say the city, perhaps the neighborhood, the square or the avenue, and the coordinates. As you see here, for example, I've left them like north, south, west, east, because at some point I can come back and really insert the coordinates that I'm using if I want to be really precise. Otherwise, okay, everyone can use different system. But we'll see that in the future it will be important to have, say, kind of standard, because our idea is really to have a platform which can help the users of the platform to collaborate. And so we'll see that at some point we'll need to have some kind of standardization in this kind of stuff. So once I have provided the title to my network computation request, I can find the place in the search bar and click for it and search for it. Say the platform is connected through an API at OpenStreetMap. So it's like kind of, say, maps, Google Maps, something like this. So we'll find several, say, places. And once I select one, below, the map of the place that I'm looking for will open. Clearly, I can use the mouse and move the area as I want. In a sense, if this is not exactly the place I'm looking for, perhaps I can go on the other side of the river or below the park here. So I have the freedom actually to move the map really a lot. And one constraint is that I will have only 2 zoom levels, which are, if I'm not wrong, 16 and 17, for the reason that I was mentioning before. Since we are modeling, say, an area which actually is covered by an high voltage to medium voltage substation, without putting any, say, limitation on the zoom, one could try to have, for example, say, the network of a whole city, but this will not work, will produce an error. So in order to avoid this kind of issue, we have preferred to, say, have the zoom level to provide only 2 zoom levels. And the tool automatically, if the area is too big, will select just a portion of it. So once the region has been identified, so I'm sure that this is the region, the area I want to work, because on this area, I have data about it. So I need to capture the map, and as soon as I capture the map, the latitude and the longitude and the zoom level will be stored and passed to the server, together with the coordinates which have been projected into kilometers in this part of the figure. Once this is done, so I have the map, I have the latitude. I want you to notice that as soon as the map is captured, there is kind of a red square inside it, which means that the map has been captured. As soon as I have taken the map I want to work on, I will have to input, and now comes the information from the user side. I will need to tell to the platform where the high voltage to medium voltage substation, where is located. And so I can make this by clicking through the mouse into the map. For example, in this case, I put the substation here. In this case, the substation is not really here, or just an example I wanted to use to show you. Once this is done, we can move forward, transform, push on the transform, and what the system is doing is converting everything into kilometers, because now we are working inside the model with a projection of the map. And we finally get into these parameters part. The parameters part actually is the part where the users needs to input the information they have about the area they are working in. Okay, what we are asking here is to have an idea of what the power factor is. As you can see here, these are numbers which are given by default, but clearly if you want to make, say, a realistic simulation, you will have to input, say, realistic values. So in this case, the power factor is 0.95, which is kind of common, but okay, if you have really information about reactive and apparent power, so clearly you can input there the right number. Here, we were thinking to provide the user with 4 choices, which are related to the ratio between high and medium voltage substation. 132 kV to 20 is common, it's quite common, but we have seen in our data sets that there are many cases in which these ratios are different. Perhaps 110 is commonly used. Sometimes there is 30 on the other side. So we were thinking really to have the possibility here to have at least 4 choices that the user can take from, in such a way that clearly the network is realistic and is representative of the area she's working on. With respect to low voltage, we assume that this cannot be changed, it's 0.4 kV. And the other numbers which need to be input here are the density of metering points, which means the number of, say, points where electricity comes. So really, I specify metering because it's easier. If you say consumers, people can be a bit, say, confused about this number, while we are talking about metering points, which are usually half or even more than that, the number of users, consumers. In terms of demand, we need to provide the maximum demand on medium voltage consumers in the area, and also the maximum demand of low voltage consumers in the area in kilowatt. Then there is this, say, 8 2x4 boxes here, which needs to have an idea of how these metering points are distributed around the different buildings. Okay, what we are doing here is not really, say, assigning for each building the demand, because once we provide this kind of distribution, the system will say allocate this demand on the different buildings. So I cannot say building which is here in this coordinate will have this demand, but this is just a way to provide, say, an aggregate way of in an aggregated way the demand of this area of interest. So to make an example, in the first part, I will have in the first row, sorry, I will have to tell, okay, imagine I have perhaps 5 people in each building, or 5 metering points, sorry, in each building with the probability of below 15%, 10 metering points with the probability of 25%, 15, for example, metering points with a probability of 35%. Clearly the sum of the probabilities, sorry, needs to sum up to 100%. And these kind of numbers can be extracted if you have the demand of a given, say, area. You imagine that you really know the demand, sorry, of a given area, you can estimate this kind of figures, this kind of probabilities. This is something that at the moment works this way. Clearly, through the use of the platform, we will have to understand if this is the right way, if there is a smarter way to make this. This is something that we will understand in the future as soon as we have a critical mass of people using the platform, making simulation, and really try to understand if this is the best way or there are better way. And so we are really here to hear from you, which you could be potential user of this platform. And so, yeah, it is quite important to receive feedback from you. Usually we are contacted by people which are quite excited to use the platform, but then we don't hear back from them. And I think this is not what we want. We would really like to have more interaction with you. Said that, still we are in the parameters page, but okay, in my slide I could not put everything in the same slide. So there are the features of the substation. So the medium voltage to low voltage substation, lower and upper limits in kVA. And then based on the, say, the numbers that I've input here, for example, I have one of the 4 potential, say, catalogs that are providing, say, the technical, so the infrastructural, say, numbers that will be used inside the model, which will be built based on the data that the user has input, and also based on the different data that we have inside the platform, which comes from the distribution system in the area, say, of interest. Imagine that I'm doing, in this case, for example, I was doing the simulation for the city of Rome. In our DSO observatory, we have for example, the network operator of Rome. So the data from this operator can be used to make this simulation. Clearly, these numbers that you see here are not the data which comes from the distribution system operator. I want to make this clear. These are, say, catalogs of infrastructural data which you can find, say, in several places. Even I think Panda Power offers a huge amount of say, technical parameter about cables, like about resistance, ampacity, voltage, etc., etc. So once we have done all these steps, it is the time to select what we want to get from this model. So which kind of files we want to get, which files we will use to make our power flow or say OPF analysis. So in this web page, I can select all of them or just those which I'm interested in. There are mainly, I would say, 3 kind of files. There are the shape files, which are the .shp, shx, and dbf, which are those which can be used from GIS, say, tools, also from R, from Python. So these data are commonly used from people that are more familiar with GIS, say, tools. And there are the MATPower files, which are mainly used from people which are more comfortable with MATLAB, especially with the MATPower, which is the tool, the routine for power flow and optimal power flow simulation. And you see there the MATPower in the top right column. And also for those which don't like GIS or MATLAB, which are in Excel file. So once you have Excel, you clearly can read the file in Excel and work, for example, in Python, or you decide. currently, there is one PhD student, which is starting with us next month, which is already try to convert files from MathPower to PandaPower, which is the Python, say, package to make power system analysis. I think there are also attempts online, but if I'm not wrong, they are not quite, say, reliable in certain cases. So that you can select all of them or only those which you want to receive. And as soon as you have select them, you need to submit your request. But before you submit your request, we think that we had thought that could have been, say, better for the user to have a summary of all the data that have been input in the same page. And this is actually what is here. Here there is everything, all the information that will be passed actually to the platform to make the calculations. So in one single page, so the latitude, the longitude, where the substation is, etc., like all the input that has been input by the users, like 132.20, the maximum demand, all these, say, and here, for example, is that kind of figure, the probability or frequency distribution that I was mentioning with respect to metering points or consumers. Okay. Once I have submitted my request, I can come back to the dashboard and I will see my request that is queued. As soon as the simulation has been is ready, an email is received from the user, which says, okay, you can now access your Dynamo platform and get your the result of your simulation there. Something that we are thinking, and actually we have already started to develop, is this idea of a city project. So through a city project, you will be able to share your network models with others. So, and from their side, they will be able to connect, for example, their network to yours if they are clearly in the same neighboring area. The idea is just that of producing bigger networks, for example, to cover whole cities, as the result of the collaborative effort of various users which are interested in the same, say, area. Something that also I mentioned at the beginning of this talk was that we want several stakeholders to get involved in this, and especially from the distribution system operator side, we would like that at some point they are also involved, because they could have the role of validators. They could really help, for example, a group of people, of researchers, to get their network validated. And so once a network is validated, which means the DSO says, okay, yes, this is quite realistic, it clearly is not the same of the network that we have in place in this area, but is quite representative of this part of the city. As soon as we get the flag, the green flag that the network has been validated, this network clearly becomes a model which can be used from a lot of stakeholders, of scientists, of companies or startups. And I think that this can become, say, an incentive for sharing more data and for having more, say, chances to coordinate together with other, say, scientists or non-scientists to really produce a common, say, common tool which can be of use for everyone in order to help in this, help fostering this energy transition that we are facing in this year. So to conclude, yes, I here, especially, I wanted to give you, to write some link, for example, to get more information what we are doing, and also a contact where, which is this GRC DiNeMo function or mailbox where you can write if, for example, you don't manage to make your question in this session of the webinar, you can send your questions here. We will try to reply to you as soon as possible. But yeah, to conclude, I have provided you with more or less the idea what is behind this DiNeMo distribution network model platform, and passing through the DSO observatory, which was actually the starting point for this to getting up to this point. And thanks to this data collection, thanks to the collaboration of distribution system operators, which have actually have believed in this project, we've been able to create these representative network models, which have been already used for several works from several research center and university to make, say, work on it, of integration of electric vehicles or smart grid projects integration, or even for smart metering, say, protocols, testing. So as soon as you have a tool which can have, say, a use in the sector, it's good to share, because there could be so many use that you even can't think about it. And then, so based on this idea of representative networks, we have done this step of making a platform, which is, I can say, still perhaps at the beginning, because we are still really at an embryonic, say, stage, but that I think has the potential to grow and to help more and more researchers to really achieve their goals. And with that, yeah, I want to close here my explanation of this DiNeMo platform, because I wanted also to listen from the audience, try to listen, to have some feedback about it, about the idea, about what we have done. And also I would like to propose to those which are interested in, because perhaps some people in the audience will say, okay, nice, but okay, not my stuff, I'm not really interested in this. I would like to really propose to those which are interested in DiNeMo to have a more, say, technical webinar in as soon as the new version will be deployed. So this means will be online in such a way that we can really have kind of more hands-on webinar. And that's it. Thank you.
Thank you so much, Giuseppe. Thank you for sharing about DiNeMo and for your efforts to move from 13 representative networks to developing the platform. If our participants have questions, please do leave them in the chat box and I'll take them. Meanwhile, I wanted to check with you, and you touched a bit upon this. What is the involvement of the distribution network operators with this project? How many models so far have you validated?
Okay, thank you for the question, Myriam. Actually, we had the possibility to have a trainee student here, and from Croatia, and she was really interested in DiNeMo, and finally we managed to interact a lot very strictly, since okay, she was from Croatia and the DSO was also from Croatia. So to validate a network, we did the publication about this, and it was really a nice experience to have. Okay, first of all, we had really a very collaborative person from the DSO side. She was really amazing. She was really helping a lot, and really was really nice to see this kind of collaboration between industry, distribution system operators, and a young scientist. She was a trainee, so was at the beginning of her say career, And but she was really, for us it was really nice to have this stronger, say, interaction, because so far, apart from this case, we have say received the data from the distribution system operators, which clearly we cannot share with anyone, but we are kind of say using their data to make something which can be useful for everyone, which is this Dynamo platform, which clearly is not providing data directly to the users, but is providing models, and these models can be used and can be very useful to make power system analysis. And so this is more or less the idea behind this project.
One thing is not clear for me. Let's say we go in, select an area, go through the process and receive, let's say, the OpenDSS file. How do I validate this network? How do I make sure this is a good enough representation of the actual network without support of my local network operator?
Yeah, okay. Thank you for the question. So actually, this is exactly what we started to do in this publication that I was mentioning, because there we discussed a bit how the validation should work, because clearly the validation we have in mind is a kind of a statistical validation. What you can benchmark is not the fact that you have the cable which is passing exactly in the same, say, street in which the real cable is passing, but what you're doing is kind of statistical, say, validation, where, for example, the number of medium voltage to low voltage substation is kind of the same or very close to it. So in this paper, we discuss this kind of issue. And clearly, what you need to do is to use indicators, the same indicators that we have identified and built in the DSO observatory, and make a comparison between what you have in the network, which DiNeMo is giving you as an output, and the network that, for example, your distribution system operator has giving you, or imagine the same DSO can make this by just looking at the network that they have, if it's not in OpenDSS, in some other, say, software they use.
Okay, thank you. I got a question on how long it takes to run a query, and I'm wondering if you're stopping the queries now and waiting for the new version to be out, and when this will be out.
The query, you mean the network computation request, right?
Yes, yes.
So, okay, actually we have started with a small, say, machine, a small computer hosting this and making the calculation. Actually, we have discovered that the problem was not really due to the time needed to run the model per se, but more to the fact that the communication needs to go from, say, one JRC site to another site and then send it back. So what we are trying to solve in these weeks with our IT developer is to try to, say, minimize the time of simulation, because if clearly this depends on the users that are using the platform at the same time. As you saw in the presentation, as soon as you make the request goes in a queue, and as soon as the CPU finished, can clearly process your request.
Is this hours, days, weeks?
Okay, if everything is working fine, it can take usually less than 1 hour. Even I think sometimes I've done, say, simulation inside the JRC, and was even 20-25 minutes, depending on the usage of the. This is something that we will actually start to measure as soon as we have more and more, say, customers connected to users connected to it. And you also were asking about the fact if now things are stopped because we are launching DiNeMo. No, we believe in the continuous development. So the service now is still on. It will go, when it will go down, just to update the new code on the platform. All the users of the platform will be notified that the platform will be down for, say, 1 hour, 2 hours, and then that's it. What we do usually is that we have a testing branch where we can do all the tests, and as soon as the tests are 100% fine, we take the code and we put it on the deployment say branch.
So maybe the participant who is having a problem, maybe they should just request the simulation again.
Actually, yes, we have faced some problem lately, and there was a problem. Actually, I don't remember well, but what the problem was that there was an issue with one request. I don't know why, but everything was kind of stopped because of this request, because of this serial. So now what we were thinking was to implement a system that after, say, a certain amount of time, which is, imagine the average time which takes to get a simulation done, the request is kind of thrown, and perhaps just the manager has been notifying that there is a problem with this request, but the other request in the queue can move, say, forward, because otherwise this can create problems.
Okay, so we have a couple of technical questions. One of them is on the algorithms you used for the representative network creation. So let's see.
Yes, actually, the core of the...
You see the question?
Ah, okay.
Oh, sorry. Yeah. So if you can just have a quick look at the question, because the participant said that so the creation of those representative networks are taken from computational geometry world. So how did you choose those algorithms, and why did you choose? So this
can I see the chat? Where is it? Okay.
Yes, you could. Yeah.
Okay.
So
Okay.
from Mirko.
Who is? Ah, Mirko.
Maybe take a bit of time to read it if you want.
Yeah. Okay, yeah, something that I can reply is that, as I mentioned, say the core of DiNeMo is complies with the reference network models, which was used by IIT, Comillas Pontifical University, to make these representative networks. So at the moment, the core of the platform is, say for us, is closed. So we don't have access to the source code. And yeah, as Mirko is mentioning, exactly, these are the algorithms that are inside, but at the moment we cannot touch, say, the algorithm, because actually for us is an executable file which is at the core of the platform. In terms of these changes, this would mean that we need to have access to the source code, and so discuss this with the provider of the executable, which is the Pontifical University of Comillas. And clearly, at the same time, there is also the possibility to have, and I didn't mention this in the presentation, but the idea at some point would be to start to go towards an open source, say, representation, open source code of the DiNeMo. But okay, we'll have to understand how to make this step, because the idea is to have something like similar to what we have now, reliable as it is DiNeMo now, but for example, that can be also modified from users which are skilled about it. And for example, in this case, I understand that Mirko wanted to already to propose something about this, about the algorithm inside the RNN.
So following on that, we had a couple of questions on the validation. So how are you validating that these are representative?
Okay, first of all, another thing that is related to the fact that we are stick with this RNN is because this tool has been already validated since several years. The RNN has been used by the Spanish regulators to make say these proxy networks to pay, for example, distribution system operators in Spain. So from this point of view, the tool is quite known, is quite powerful, and is say reliable, just say for this reason. At the same time, as I mentioned, once we want to validate our networks, we really need, say, the collaboration of a distribution system operator of that area. Otherwise, it's almost, say, impossible to say, okay, this network is okay or it is not okay. What we have in mind is clearly the fact that users will not just input the data like this, like just say random data, but there will be, say, serious users which want really their network to be validated. So what we are thinking now is how to start this process of say validation between users, which can have big amount of networks to be validated, and distribution system operators. Try to understand which kind of mechanism we need to foster to make this possible. Otherwise, clearly, you can get your network, but the network, if it's not validated, is really something that is not 100% sure, even though the tool is, say, a solid tool. I don't know if this replies to the question.
One example I think we definitely need, or we most likely need, the cooperation of the DNO is the location of the transformer.
Mm-hmm.
It's not obvious where the transformer is in an area. So if you don't know that information, you'd want to ask your DNO, and they might not want to share it.
Okay, you mean the high voltage to medium voltage, or the small
MV
one?
to LV, yeah, the small one.
The small, okay, for the small one, actually, again, I think it's not really important to, for example, get the exact position of the transformers, the medium voltage to low voltage. From our point of view, it's more important to have, say, an idea of if the number of, for example, medium voltage to low voltage substation is the same of the real one. If this is the case, I think this is enough, because having the, say, the exact position can be an issue because of security issues, because of cyber security attacks, because of so many things. So instead of getting the real, say, position, having, say, this kind of representative then network can be, from my point of view, a good compromise, which I think DNO could accept. And I'm sure that if there is interest in this, and if there is discussion how to, for example, the validation is clearly a key part of this work. And if we manage to get them involved, and because there are a lot of users which want to participate to this project, to this idea, I think we'll manage to find a way to make this possible.
You think the DNOs will help you validate the networks rather than just maybe giving you access to some of their networks? Let's say that, I'm assuming here they're interested, they want to support something. They might just give you access to their network models.
Actually, my vision is a bit different. Let's have a kind of, let's improve our methodology to make the validation. And let's give our models with the methodology to the DNO, and just to help them to verify. If they don't want to provide the data to us, we can give, say, the data that we have to them and ask them to validate if they have, say, a specific methodology. And say from the, say, DNO part, DNO side, I think that as soon as they see that by using more realistic networks, they can get information about their own networks, imagine that I can tell, based on a representative network, that 40% of electric vehicle integration can collapse the network in certain period of the day. I think this is something that is quite important for them,
No,
and can be of interest.
Oh, for sure,
Without,
and
yeah,
yes, no,
without the need to share the network. So from the security part, they are fine. But perhaps the real number will be not 40, will be 43. But for them is something, okay, we are producing, say, some knowledge that wasn't there. And we can do this through models which are, say...
And I suppose there is a range of the capabilities of the DNOs. And I'm not going to name, but some DNOs in the UK do have quite a good visibility on the network. They do have a kind of a master digital network model.
Mm-hmm. But
no, but some of them, not all of them.
Yeah, because it is really, from what we can see, is really, so the Virtus are really a small subset.
Yes,
but
yeah.
there
So
are there are many which have don't have that knowledge. Yeah.
So from that side, we are filling a gap of these DNOs that need to catch up. And on that point, we have a question, or how do you synthesize grids in regions where you don't have DSO data on?
Usually we use, for example, average in terms of, imagine that I have the data from for the city of Munich in Germany. Okay, if the simulation is in Munich, okay, fine. Otherwise, I will use, for example, the data for Germany, or for the area, for the federal, say, yeah, depends, the closest area to where I am, actually. In the current version of DiNeMo, I'm using the country, information is at country level. So all the information is, say, averaged and considered at, say, average at a country level. So if I go in UK, I will get the average values of UK. But the idea is that we can really go, say, closer to the data that are closer to the area. I don't know if I explain myself. So the idea is that the platform will have to select the closest data in relation to the area. So given the geographic coordinates, can really understand where is it. This is still in the to-do list of things.
Do you foresee the usage of DiNeMo outside the academic world? Do you have examples of consultancies or companies or startups?
What I can tell you is that, okay, but I at the moment, I don't know what they are doing with it, but I know that there are several, say, startups and companies which have asked to access DiNeMo and which are running, say, simulation. But okay, I don't know what they are doing with it.
Possibly like they want to test some sort of optimization.
It could be, yes, it could be. If you want to test a solution, for example, having a network which has, for example, the same, say, topology of the area you are working in, it can be already a lot of stuff instead of using some kind of IEEE network, which is also thought for transmission or for distribution. So I think is can be can be useful.
And more information on DiNeMo itself. For example, if we wanted to learn more what you meant by metering, point per building, etc., we can follow the link you provided, and there should be documentation.
Okay, at the moment we have guidelines that we share as soon as we receive the request to to DiNeMo. We share we have the idea for the future is to have something really online. So if you go on the question mark, you know what is what you need to input in that record of the platform. The only problem that we have at the moment is, okay, first of all, the pandemic, and second of all, that the resources available to work on DiNeMo are me, just an IT developer. So I think that if there is really an increasing interest in DiNeMo, this would already mean that more resources are needed to work on this project. Because if research center, university, startups, companies are interested in this, clearly these deserve more, say, human resources. And for me, this would be really rewarding.
Thank you. So on that note, if there are questions that I didn't capture, I'd encourage people to please contact you directly. I'm assuming that's okay, of course.
Yes, indeed.
Anyway, a couple of minutes. So if there's something you'd wanted to ask and I missed it, write it again. I also want to say that a couple of participants shared very useful information, such as there is data available on the OSM, open source map, I'm going to assume that, and also some DSO that publish all its data, and there's a link. I haven't checked, but...
Okay.
Yeah, so,
okay, if you can share with me these, because...
So they are in the chat box, and anyway, at the end of the meeting, I'll send you all the questions as well.
Okay, thank you very much.
My last question for you is, at the Turing, we're developing a tool to help automate collection of data and analysis of data. And one of the things we're doing is inputting to OpenDSS to build the network model and also to simulate the network. Do you foresee your tool as a module in such a modular tool where we can plug into your tool to put some input, build the network model and run the simulation, or this is a standalone, it cannot be part of something else?
Okay, as it is now, cannot be part of
Oh, here we go. Someone just asked, sorry to interrupt, someone just asked, when will your source code be put under an open license so that others are enabled to do so?
Yeah.
In case he wants to know if there are plans to generate grids for large regions, in my case, I want to be able to use what you've done. So yes, definitely an open license would be needed. And you're saying the case now.
This is something that we have in mind for the future, and which we need to understand how to tackle for sure. I'm sure that in these years there will be a lot of, say, work on distribution grid, because it has become clear that the transition passed through the distribution network. All the renewables, all the storage system, all the electric vehicles will be connected to the distribution grid. And so it's really fundamental to close the knowledge gap that exists at the moment on distribution grids. Also because the distribution system operator or network operators are now becoming, say, an active player into the power system. And I think this will be, say, this will be something really good for us that are working on this fascinating topic.
Great. Okay, excellent. Thank you so much for the excellent presentation. There are comments in the chat box which I will send you, and I encourage people to contact you directly and to try DiNeMo.
Yes, I've shared here the contact. JRC DiNeMo is Europa. So please contact me. I'll try to reply as soon as I can. And thank you very much for your time, and really send me your feedback if you think that is you like what we're doing.
Thanks, Giuseppe. Bye.
Thank you very much. Bye bye. Cheers.